All right, 3-3s on graphing systems of inequalities. So basically it's what we did last chapter where we graphed a line or an absolute value function, did the shading, but you're going to look for where these things overlap. And then all those numbers that are in the overlap are answers that work for, in this case right here, these two inequalities, but you could have 3 inequalities, 4 inequalities, you could have a whole pile. That's called a system. So I'm just going to go ahead and graph 2x plus 3y is less than 12. That's in standard form. So I plug in the zeros. When x is 0, 12 divided by 3 is 4. And when y is 0, 12 divided by 2 is 6. So my y-intercept is 0, 4. My x-intercept is 6, 0. I'm going to connect them with a line, but I'm going to remember that what kind of line I need to use on these. The line I need to use on these is dotted because of the less than. This is just a less than, so you got to remember to use a dotted line for that. I'll go ahead and activate a dotted line, and I'll go in red since I use red dots. Then I have to decide which way to shade. Again, when I decide which way to shade, I could plug in a point. I could plug in like 0, 0 is a good one to plug in here. If I plug in 0, 0, I get 2 times 0 plus 3 times 0 is less than 12. So I get 0 is less than 12, and 0 is less than 12. That's true. So I need to go ahead and shade everything over this direction here. Okay, so far my answers for the system are anything that are below this dotted line that I've just drawn. But maybe this other line makes it so that some of these don't work. So I'm going to graph this other line. This is in mx plus b form. Has a slope of 3 over 1. Has a y-intercept of -2. So I go down 2, put a point. And then the slope's 3 over 1. So I'm going to go up 3, 1 right. Up 3, 1 right, up 3, 1 right. And this one's going to be a solid line because it's greater than or equal to. I'm going to draw a solid line through those. And it's going blue. Go, and then I have to decide which way to shade. I could plug in a point that's not in here. 0, 0 is not on there again. If I did that, I would get 0 is greater than or equal to 3 times 0 minus 2. I get 0 is greater than or equal to -2. So in this one, 0, 0 is also an answer, because that's true. Otherwise, it says y is greater than, and where are y is greater than? Y's are greater than when you're up. In this case, let's say I looked at 0, 0, and that's above the line. Now pick a point that's directly below there, that's below the line. Which one has a bigger y? Well, the one that's at 0, 0 does. So that's another way to tell that we should shade this way. Now, we also shade up here, but that really doesn't matter. What I'm really interested in is this region right here where they overlapped. This region right here, I'm going to shade in real dark there so that I can tell where the region is. Now, anything within that region is a solution. So you're going to just, down below I said pick 3 points. You're going to pick anything that's in that region. So negative, that's in the shaded region, -3 is 0. How about this one right here, 0, -2, is that in there? Well, since it's on the solid line that represents an edge of the shaded region, it is in there. So 0, -2 is in there. What about this one right here? Is that in there? That one's an edge of the shaded region. No, that one isn't though because it's dotted. So be aware that if it's a dotted line, points on there are not included in your answer set. So what's another one? Anything in here? -5, 0, -5, 2, any point in here, pick some other point. I'll go with -5, 0. Get another one going here. This one has an absolute value. So this is reminding ourselves of how you graph an absolute value. When you have an absolute value, you get a V, and the V has a vertex. And remember, the vertex is whatever makes the inside of the absolute value equal 0, which is -4. This says +4 inside, so that means 4 left, so we'll have -4. And then with the last number is what you would have for an answer if you plug in -4. That means 5 down. So you'd have -4, -5. When you plug in -4, all this cancels, leaves you with -5. That is your vertex. So we'll go ahead and graph that. Now the number in front is our slope. The number in front is 3, which is 3 over 1. So this V opens up. Just go up 3, 1 right, up 3, 1 right, up 3, 1 right. But to have a V, we also need to go left. Up 3, 1 left, up 3, 1 left. This had a greater than symbol, so we're going to need to use a dotted V. And then we need to decide which way to shade. Now you could plug in 0, 0 here, but it's easier to plug in something that's on the axis of symmetry, like -4, 0. That's on the axis of symmetry, which would be x equals -4 in this case. So we're going to plug in -4, 0 to see if that works. If I plug in -4, 0, it looks like this. 0 is greater than. -4 plus 4 is 0. Absolute value, that's 0. 3 times 0 is 0. So you're left with 0 is greater than -5. And that's true. So that tells me that I need to shade inside because 0, 0 is inside, and we want that to be a solution. Another way to look at it is it says y is greater than. So I pick a point that's inside and pick a point that's on the outside. Just make sure they're in the same vertical line. Which one has a bigger y? And you can see that this one here has a y of 0. This one down low here has a y of -7. So the one up here with the y of 0 is bigger. So that's another way to tell that we should shade inside. Y is less than or equal to 5 is a solid horizontal line. Has a slope of 0, but we just need to get the line in here. And where is y less? Well, y is less down. But do I care about this stuff outside? Not really. What I care about now is this stuff here. So far, my answers are represented by that isosceles triangle that I've just shaded. Well, not done yet because I got to graph x is greater than -4. When it's x, you have a vertical line, and it's -4. So I'm going to go 4 left and put a vertical line. That's actually the axis of symmetry. I made it dotted because it doesn't have an equals. And where is x greater than -4? Everything to the right. So where's the overlap? Well, I got a little messy here. The overlap is, we'll try to fill it in nicely, this right triangle right here. That's where all 3 graphs overlapped. So that's really all I need to see in your answer is that area right there. So if you're going through it and you know, okay, I'm going to shade down, I'm going to shade, to the right. You can pick out that area without shading each individual one. I'm okay with that. Just make sure that you are clear as to what the overall final shaded region is, and then be able to pick out some points that are in that region. So if I was going to pick out some points, I might say, let's see, it can't be on -4 because it's dotted. So how about -3, 2? -3, 2. That looks like it's in there. How about -3, 4? That's in there. And then could we do -3, 5? Yeah, we could because, again, that's on a solid line right there. So -3, 5 is on there. It didn't have to be -3. You could add -2, 5 or -2, 4. Just make sure you stay in the shaded region. And then we had some word problems. Not everybody's calculator is set up to do this, so I'm just going to set up the first word problem to give you an idea of where we're going with this. When we do word problems, we always want to pick our x and our y. And when I just want to decide where x and y are, usually I go to the end and there's a question that needs to be answered. And more times than not, that question gives me what x and y stand for. I want to know how many of each type of seat that we must sell. So when I read it, I find out there's two types of seats, balcony seats and orchestra seats. So I want to let one of these be balcony seats sold. And then the other one will be orchestra seats sold. Now I want to come up with some inequalities. Well, right here it says that we need to get at least $30,000. So to me that means greater than or equal to $30,000. And this is money. So I need to figure out how I'm going to take in money. Well, it says you get $20 for a balcony seat. So if I had 2 balcony seats, it'd be 20 times 2. I get $40. If I had 3 balcony seats, it'd be 20 times 3. It'd be $60. How do I figure out the money I get from balcony seats? I take 20 times X, which is however many balcony seats I sold. If I sell 10, I'd get $200. 20 times 10. Still need to get money from orchestra seats. They're $30 for each one of those, so plus 30y. There's an inequality that I would graph. I'm done with this information. I'm not going to use it anymore. Once you use some information, don't use it anymore. I still have one more thing. It says the center has 500 orchestra seats. Well, be clear that it says orchestra seats. So that I'm only going to use y. Don't use x, because it's only talking about orchestra. So how many seats are there? There's 500. But y stands for the number sold. So we could sell 500, but it doesn't have to be 500. It could be less than or equal to 500. So these are the inequalities that we get based on the information they gave us. Many times in word problems, your word problems, the graph ends up in the first quadrant. And that's because your x and y can't be negative. So we should include those extra inequalities. Could I sell negative balcony seats? Could I sell negative orchestra seats? The answer to that's no. So x has to be greater than or equal to 0, and y has to be greater than or equal to 0. So keep that in mind when we're setting up word problems that need to be graphed. The next section, 3-4, we end up graphing these, and then we're going to find out some minimums, maybe some maximums, that will help us to accomplish our goal, which in this case was to make at least $30,000. So I can show you how to graph this. I'm not going to because, like I said, not everybody's graphing calculator is working well. Doesn't have the app that you need. You could do this by hand. It would look something like this. I would say that the x-intercept would be 30,000 divided by 20, which is 1,500. The y-intercept would be 30,000 divided by 30, which is 1,000. I would connect those with a solid. I shouldn't go below the axis, or to the left or below the axis, because I can't go in the negatives. I accidentally did. We want to be greater than that, so that would be out. And then I want y to be less than or equal to 500. That's my next one right here. That's a horizontal, so I'd say, okay, maybe 500 is right here. Horizontal. And then we want to be less. That's the shaded region that we're interested in right here. There should be some parameter in this problem about how many balcony seats there were. I didn't include that in the problem, but if I said, there's only 2,000 balcony seats, then you would have something right here at 2,000, not 20,000, 2,000, that would limit it to this shape right here, and you'd have a quadrilateral. But this type of problem leads us into what we're doing in 3-4, so I'll discuss that more there. I'm going to call it quits there. We've gone almost 15 minutes, so I'll just say thanks for watching. Make sure you ask questions if you've got them. Have a great day.